Trading doesn't
Sir,
really.
your voice is very low, sir. Please speak loudly, sir.
I'm so sorry. How about now? How about now?
It's okay, sir.
It's good now? Okay. Is it better than before?
Yes, sir.
Okay. That
Yes,
sounds
sir.
good. Okay. So threading doesn't really give us any benefits in Python, and that is because of what is that because of? That is because of the starts with G. Okay. Uh, I hope I'm audible now, right? Okay. Okay. All right. So yeah. So what we know now is, threading doesn't really give us much advantage. Let's go back to the presentation and try to understand how the GIL works, right? Shatendra, is that a useful little experiment?
That was actually, if you ask me, I mean, anyone else can also just sort of chip in with their, if they want anything. So from you, they can just directly ask you. I think this is that kind of a session. So I
Yeah.
think you've been very friendly. So, students, I do encourage the students and everybody else really. Please directly you can ask Shomlaka to repeat or, But I think it was, if you ask me, I think it was quite a bit of an eye opener.
Okay. Okay. Cool. All right. That's yeah. So just guide me along, saying, okay, this doesn't make any sense. Try something else, or just give me some feedback that okay, this okay, now I understand what you're talking about, right? So all I'm trying to say is in Python, so in C or in really anywhere else in the world, threading is supposed to give you more performance. Uh, but in Python, threads are locked because of the GIL, the global interpreter lock. And that's why only one thread can run at once. And therefore, the time taken is really the same whether you spawn 2 threads or 4 threads or how many ever, right? That's the conclusion here, right? Okay.
Yes,
All
that
right.
makes sense.
Okay, yeah, that's okay. So let's try to see, how we can bypass this. I mean, I can probably come back if we have time. I can come back to how exactly the GIL stops things. Uh, let me see if I can. Yeah. So this is basically what it does. Okay, it it has a tick counter, and one tick is roughly equal to one of these basic interpreter instructions. Okay, like load const and compare and jump and pop, and the basic operations is one tick, and it goes through 100 ticks, and then it resets the counter. Once it reaches 100, it resets the tick counter. It it forget about this. It releases the GIL and sees whether, actually, it just signals to the main thread that, okay, now's the time when you look for the GIL, releases the GIL, and if nobody, and then whoever has priority acquires the GIL, right? So let's probably not get too far into how the GIL works, but it basically, let me see if there's a little summary slide somewhere. um, yeah, let's look at this guy, right? uh, Sorry. Actually, yeah, this is very nice, right? So this is kind of how the thread switches. So thread one runs, 100 ticks, finished. Then there's the check, and when you check, you release the guild, and you hand over control to the OS, and then some other thread based on the priority will acquire the guild and start running. Okay, so that's kind of how the guild works from a very high level, right? So and who gets priority is managed by the OS. So you might have a situation where things like this happen. Thread 1 is high priority, 100 ticks, check, hand over control to the OS. OS says, you're the boss, take back control. And it keeps running. And this guy never ever gets to run. This second thread of lower priority never ever gets to run, right? So yeah, that's kind of how the guild works and what the guild does. And the other thing we've done is we've actually gone in and checked that, yep, that's how it is. And therefore, we have 2 into 35. It takes 4.95 seconds without anything. We run it on 2 threads, still get the same. Let's try to see if it ever gets any better. Okay, let's try to see if it ever gets any better. And for that, we're going to look at what's called multiprocessing. Okay, so threads are managed by the OS. I mean, processes are also managed by the OS, but they have to be independent and they are not locked by the Python interpreter. The guild doesn't affect processes, they affect threads. Okay, so you could have data generated from 1 million records. You can use one single worker to load it into a database, or you can actually have multiple workers and send, sorry, not 1 million, that was 100,000 records, 100K. So you could send 25K to each of them. And they would finish in 1/4 of the time, more or less, and your entire process would happen in 1/4 the amount of time, right? And this is not stopped by the guild. That's the good part. See, threading also works like this. I mean, the different threads should be running independently and they should be, getting your work done in 1/4 of the time. But alas, Python has guild and it doesn't allow the threads to run separately, but it does allow processes to run separately, right? And that's what we're going to try next. Okay, so we're going to take the same example. Sorry, not this one.
Just one small request to everybody who's listening in. If you are logging in from your mobile phone, please enlarge your screen to full screen. So pin Shomdatta down to the screen and then enlarge the screen. That way you'll be able to see better.
Yeah, pin my presentation. Yeah. Yeah, that's a good idea. Okay, so I go on. So I go on.
Yes, please. That should be ready by now. Yes, please.
Okay. So how far have we gotten? We understand what the guild does. The guild doesn't allow us to run multiple threads. So what we're going to try is to run multiple processes, which is not stopped by the guild. And we have also run a little experiment of our own, trying to run Fibonacci on 2 numbers, measured the time. It takes 5 seconds, more or less. We throw it onto 2 different threads, but because of the guild, they don't run independently, they don't run simultaneously, and therefore it takes pretty much the same amount of time, 5 seconds, right? So threading doesn't give us any advantage. We're going to try multi-processing, okay? So how do we do that? Right? So that again has a library that has a package called multiprocessing. We import a process pool from there, okay? And in that process pool, what we do is, here's how we write it. We say with pool, let's say processes, oh, sorry, processes 2 as pool, right? So we define the pool and we say R1. So this is the first one. So just like we did threads, okay? Pool dot apply async. What was the thing? Fib list. And we're going to put the same stuff in there, okay? We're going to put args equal to n list f, and then we're going to have an R2, which is going to have n list s, okay? Same thing, just this time it's process, not threads, okay? And we run those processes on a process pool, okay? And okay, right. And then what we do is, yeah, so then we have to, so pool starts by itself. You don't have to actually start it like a thread. Pool starts, and you just have to gather the result back, right? So you say R1 dot get, so let's say R equal to, put it in a list, R1 dot get and R2 dot get, okay? All right. And finally, you can just print R, and we will bring in our duration, our best friend, right? So we say duration equal to time dot time minus start, and we have to define start, right? Time dot time, right? Okay. All right. What do we have here? Okay. Let's run this. Oh, we should be. Thank you so much. Thank you. Yes. Lovely. That's the debugging I'm looking for. Who sees the magic? Okay. So let's just do a round. I'm just rounding it to 2 decimal places so that it just looks a little neater. And there. Do you see that? Took 5 seconds with threading it sequentially, but now it takes 2.62 seconds. Okay. Okay. Because it is not restricted by the gap. Okay. So everybody with me?
Yes, sir.
Yes.
Awesome. Awesome. Great. Okay. Okay. So now let's go back to my presentation, right? So this is exactly what happens. Those R1 and R2, those are your multiple workers. Okay. So what I did is very simple. What I did is I took the task fib list. I defined what the inputs are. You remember what the inputs are? You remember? Right? So we run it, and that's your end list, right? So 35, 35. Okay. Same input, it takes 2.7 seconds. So basically, fib list. So this is the first worker. This is the second worker. You just throw the jobs onto these different workers, and you get the result in half the time, because both of them are running simultaneously, and each of them is processing just half of the list, right? Okay. Okay, great. Okay, so now the problem is, as as you start making more and more complex programs, it's not enough that the it's not enough that you have just one worker per process, right? Because a process is typically what runs, I mean, one CPU can, these days you have multi-core machines, right? And each CPU can pretty much run one process, right? And it's really hard to find systems which have more than like 16 cores. Like that's like a humongous system. Okay. So if you want more than 16 cores, what do? You actually need to be able to run on multiple systems, which is where distributed computing comes into the picture. And the next hero can actually run on a cluster, and that's called Dask. Okay, so this is again, I'm going to add a link to Dask. Dask is a very favorite library of mine. You can Google, and I will add. So I'll share this presentation with you so that you have this as a little reference. You can try things out, right? So Dask is like a distributed computing library. If you want to run like Fibonacci over 25 computers, your workers can actually go onto these separate computers and get the job done, right? So it's like a worker orchestration system, right? And that's our next next library that we're going to try out. Okay. 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 Did we understand, why we don't stop with multiprocessing? Why do we need Dask? Can somebody tell me why we need Dask? Can somebody, if nobody can tell me why we need Dask, I want somebody to ask me to repeat what I just said. Okay.
Sir, because Dusk is a open source project.
Yes, but I mean, I could make an open source project which is completely useless to you, right? So
Yes, sir.
you wouldn't use it because it's useless, right? But what why do we use it? I mean, why can we not just stop with multiprocessing? That's also open source.
Because
Go ahead. Go ahead. I'll help you. Okay. Okay. the very short answer is multiprocessing can only run as many processes as one computer can support. And that is typically equal to the number of cores. And it's very hard to find computers which have more than like 8 cores, really. It's very hard to find computers which have more than 8 cores. So if you want to run like 1,000 workers, which is kind of what Google is doing, let's say, I mean, come on, everybody is searching on Google, right? I mean, it's not possible to run that search engine on just one computer, right? So when you're building models in data science with crunch all that data, so you need 32 computers. So, somebody has to take care of the task of distributing everything over many computers. Does that make sense? Yeah, I'm not really very good with talks. There's, oh, all right. Okay. Would you guys like a little break before we start with task?
No, sir, it's okay.
I'm just asking everybody on behalf of Shumlotto, you guys want just like a 5-minute break or something, just,
I don't know, like maybe a bio break or something.
something break, just to grab a cup of
No
coffee.
problem.
I mean, like, especially with our dear listeners also, if you just want a break,
Session is going fine and very interactive session. So as per
Yeah,
your wish.
so if Shumlotto permits, we can allow maybe a 5-minute break. Is that okay with everybody?
Okay, yeah, I'm fine. I have like about I think I have
That's good.
approximately.
What about everybody else? I mean, Nancy, Ishita, and let me just see if I can just bring out the list. I mean, why only Nancy and Ishita?
Students, please response.
Autoshri is Syed is there, Adinath is there, Rishita, Rishu, Shagni, Shomi,
Oh, we have about 60 people on the
Kumar,
call.
Sangasaptok, so everybody. I'm asking everybody. Would you like a 5-minute break? Also, our dear faculty members, also Bornali, Bunny Broto, Angona, everybody. Would you like a 5 minutes break? And then
Yes, sir. Yes, sir. Sure. 5 minutes break.
yeah.
Right. I'll stay connected. I'll just mute and come back. Yeah?
That's good. That's good.
Okay, sir.
Right. See you. Yeah.
Okay. So please stay with us. After 5-minute break, sir will come.
No,
And
I will. I'll be back in 1 minute.
Okay,
I'll just
okay,
I'll
okay,
just be
okay.
back in 1 minute,
Okay,
and
okay, sir.
we can just join back in at
Okay.
12:22. If any minute, I'll just be
Okay,
back.
sir.
Yeah.
So stay with us.
Yeah.
Everybody, please.
No, I mean anybody who wants to go, will not start the session before 22,
Okay.
12:22. But yeah, I'll be back. Yeah.
Okay, sir.
Sir,
Yes.
hello. Sir,
Yes.
can you explain why we use desk library?
Yes. So I just got a question from I just got a question that asks is Dask faster than pandas? So Dask and pandas are kind of used for two different purposes. Pandas is used to process data frames. Uh, Now pandas can be used with Dask, right? And pandas uses something called data frames, and you can also have Dask data frames, okay, which use pandas. But okay, I'll give you a very nice example. Suppose you want to read how do you read data into pandas? So the way you read data into pandas, the most popular way of reading data into pandas is using CSVs, right? pd.read CSV. Now, it's all good if you have, like, let's say you have 16 gigs of memory on your computer, you have 16 gigs of RAM on your computer, and you want to read a file which is 15, or yeah, it's not going to work even if you try 15. But let's say your file is less than 10 gigs, it's going to work. Okay.
Okay,
But I mean, we regularly get files which are like 200 GB. Okay. Like data files which are 200 GB. Have you ever seen a computer with 200 GB of memory?
200 GB. No, sir.
So how do you load that data? So if you have to load that data, then comes the Dask data frame, which actually shards this data over multiple computers and keeps. Okay. So then you can run pandas operations, but it's going to run in a distributed manner. So Dask is kind of a layer on top of pandas. It's a layer on top of NumPy. So NumPy, for example, NumPy arrays. If you want to make an array which is, if you want to read in an array which is 200 gigabytes, how do you read that in? It's not going to stay in the memory of your computer, right?
Yes, sir.
So that's when you use Dask
NumPy.
array. So just read through Dask. I'll update some links of Dask data structures. So Dask has something called a Dask array. It has something called a Dask data frame, which are basically pandas data frame distributed. NumPy array distributed. Okay.
Okay, sir.
Okay. So I've given you the link for Dask. If you are interested in Dask, start looking through the project, and you'll find a lot of examples which you can study from. And these questions are very good questions, very valid questions, but you'll find answers to them. Okay.
Okay, thank you so much.
Right. Let's start. We start.
Yeah, let's just go ahead, please.
Awesome. Okay. So now we're trying Dask. Okay. Of course, done it. Friend, and start, right? And in between is what we write. S equal to Dask syntax, right? So what you have to do is you have to gather some futures. And how do you create those futures? Don't worry if you don't know what futures are. And here we actually don't have to use fib list. We'll use the fib directly, right? And we're going to give it the entire n list. Okay, we're going to give it the entire n list. Splitting, which we did for into n list f and n list s, but here we just give it the entire n list and wait for the answer. Okay, and then we print s And I'm sorry, guys, I have a new keyboard and I'm not used to it yet. And end list was? Do we remember what end list was? Right? And just to recap, we ran it sequentially, 4.94 seconds for 2. We ran it in thread, 4.99 seconds. We ran it over different processes. We got advantage, 2.73, down from 5 to 2.27. Right? Fast. Right? .3. Okay. Does that sound good? So this is the essence of how you run large programs on Python. You don't get stuck because of the interpreter, but you actually distribute and compute. Right? This is another library. It's called Celery. I can add a link to it. So it's again the same thing, that it's just like Dask. It's basically a producer-consumer problem. From a queue, it goes to a worker, and the worker crunches the result, gives it back to a from the web. I have a right, serve it. Okay, it will go and come back. Okay,
And obviously, everyone.
Cool. Okay. Use normal Python. Give me a minute. Yeah, we're not going to be able to use the notebook. Just a minute. Okay. Just one moment.
Sir, why Celery not use notebook?
That's because Celery doesn't have a, so you see here we defined just a client. We didn't, so we only defined this guy, and Dask automatically created the cluster. It has a default cluster. Okay, so you can actually, there is a way to define something called a local cluster, and you can go like cluster equal to local cluster, and then you feed the cluster in here, and here you can actually change the number of workers to 2. Okay, so you can do all of that. Okay, but we didn't have to do this because Dask does the job of creating this local cluster by itself. When you define a client, it knows that of course you need a cluster, and it does it by itself. Celery unfortunately doesn't do that. So you actually have to create the Celery workers on the command line. Okay.
Okay, sir.
So that's the reason. Anyway, that's not a problem. We'll get that done. Okay. The other thing I have to do is I'll just have to go off presentation, and I will have to share that window where I'm going to write the code. right? Yeah, there's this new problem where I'm not able to share my entire screen. I'm only able to share an application. So a window. Can you guys see that? Okay. So it's just a regular.
Shambhata, just once, if you could once again just increase the. Is it possible to increase
Oh
the
yes,
font
yes,
size?
of course it is. Of course it is.
Yes, please.
Okay.
A little bit larger,
A
please.
little bit
Please.
bigger. Yeah. Okay. Okay.
Maybe that's about it. Maybe that's about it.
Okay.
Thanks.
Yeah.
Thanks a lot.
Let's try to see if this is a little similarly. Uh, try out this other little feature. It's a feature from GitHub called Copilot. It kind of auto completes code. Like like you can do this. So let's say do you see what happened? I just wrote fib n and it auto completed with a Fibonacci code. So this is this thing called autopilot. Okay, right. So let's try seeing how we do this on celery, right? Of course, we'll need fib n, our favorite friend. Oh, it's making a mistake, and greater than equal to 1. Okay, that's fine. So we need our friend fib n, and we need our friend fib list also. We already wrote that in the notebook, right? So we'll need these guys. I don't like this code. I like to change it a little. I think this is. So I just took my code from the notebook, right? So we have these. We'll need them. But first, we need from celery, import celery, and our favorite, oh, sorry, import time, right? Right. Now, so first thing we have to do is we have to define a celery app, you know. So it helps me autocomplete, but that's not what we want. We want, let's say we call this guy Fibo, and we define a backend. So that backend has to be, backend in my case will be, so backend is the queue which takes the request. I'll reshare my presentation later. I'll associate what the backend is. And that backend in our case will be Redis, let's say, simply because I have Redis running. So Redis is an in-memory database, okay? It's just it's just something which runs on my computer by default. I will use that, and you need a broker. So backend is where the results go, and broker is where the requests go. Okay, and it's going to be the same. Okay, you have a plethora of backends and brokers to choose from. I'm just going with Redis. Okay. Now, the next thing that you have to do is you have to define celery tasks, right? And this is a decorator. If you don't know what a Python decorator is, I'll add a link later on. Figure out what a Python decorators. Okay, so I'll give you some links to that later on, right? And then we define like compute, right? And yeah, we just want to define compute, and let's give it. I mean, of course, we are going to compute our favorite Fibonacci, but we're not going to return it. We're just going to do res and oh, and we're going to do our favorite thing to do, right? Let me just copy it from my notebook. Right? This is our favorite thing to do, right? Okay. So here we call it. Are we going to use fib list? No, I'm actually going to use fib, not fib list. So no n list. Let's call this guy compute fib. Okay. It needs a return. Okay. You see what I did? Very simple. That's it. Nothing else needed. You have your, yeah, actually, I don't need this. I'm so sorry. I don't need this. Just like in Dask, we used only fib. Here also, we will use only fib. Okay. We will use only fib and give fib the whole array, give fib the whole list, and fib will figure out how to, sorry, this compute fib celery task will figure out how to run over all of them and generate results. Okay. All right. So let's see. Okay. Right. Okay. Is everybody clear what I'm doing here? So I just defined our favorite fib function. We defined, you know, the celery cluster, if you will, and we started. We defined a celery task. Okay. Okay. Great. I'm sorry, I will not be able to keep. Okay, let me save this. Right. Let me save this. Okay. Just a minute. Calling it app celery. I'm saving it on my home, and now I'm just going to stop presenting this, and I'm going to start presenting my terminal. Where is my terminal? Huh? Just one moment. Okay. I'm sorry, for some reason my terminal doesn't come up. Hmm. Just one moment. Yeah, guys, I'm sorry. I'm not able to share my terminal. So So I'll probably send you a video of how this thing runs later on. Basically, you have to run it on a terminal, and I'm not able to share the terminal. It just doesn't pop up in my list of things to share. But yeah, I mean, what we've covered until now is that, you know, we have a problem where 235.7 seconds. With Dask, it's 2.3 seconds. And with Celery, it will be very similar. It will be like 2.3 seconds. I will share this code though, and I will share a video of how to run it. Okay. So yeah, as you can see, I mean, that's pretty much all I had to cover. We could probably use the next 15 minutes for questions, or yeah, I think yeah, I'm sorry, the Celery app I'm not able to run because I'm not able to show you my terminal, but I will make a video and send it along with the rest of the with my slides, the code. I'll put all of that into I'll put all of that into a shared Google Drive and share it with Shatadru. Can I respond to you with that?
That's absolutely okay, Shomlato. I mean, we do understand. Yes, you may carry on with this one, please. Thank you.
Okay, yeah, so that's pretty much all I had. I wish I could show you something on Celery, but yeah, I just kept it as a bonus kind of if we have time. But I think we're pretty much at the end of time, and my thing doesn't, my terminal doesn't share. I'm so sorry. Yeah, so that's kind of all I had.
I think that was a very, I mean, it's so nice of you to come and do this with us. And I hope everybody realizes how important this one was, because, you know, data analytics is and I did see a few data science students here, and obviously they would need to give us a flavor of that. Shomlato, is it okay if I just allow about, let's say, 5-10 minutes for any questions that might come up in their minds?
Absolutely, mail contact. So I will share all of this. It's basically in a folder. I will share the entire folder essentially. Let me just check. Yeah, so I have all my material in a folder, and I will share this folder. I'll send it to Shatadru, and he can distribute it. There's just one thing. I have a strong email filter. So what I'm going to do is I'm going to allow emails with a certain subject tagline. So please prefix this to your subject line. Otherwise, the email won't go through.
When you send this to me, Shomlato, please mention this so that I can just relate that.
I've just put it in a comment on the presentation.
That's so good.
Okay.
That's so good. So, any questions, please? Please, would you ask it to Shomlato? Everybody in the list here, everybody who's scared to join in, please.
Hello, sir.
Yes.
Sir, I have a question. I want to make on Instagram automation tool, but I don't have much idea how to start. Can you suggest any?
You want to make what? An
Aut-
Instagram automation
Automation tool, yes, sir.
tool. Okay. So what do you mean by that?
Instagram, like we have Instagram on Instagram, like all like sharing and commenting post,
Right. Right.
but we don't have time to see everything.
Okay.
So that's why I want to make like Instagram automation tool so that we can control by our automation.
No, but what would you like the automation to do for you? I mean, so you do you want to like everybody in the world, or do you want to like whenever there is a post from a certain person?
Yes, sir, certain percent.
Okay, so whenever there's a post from a certain person, you'd like to add a like.
Yes, sir.
Okay.
Like and comment.
You want to like and comment. Okay. So I actually have no idea, but usually how these work is whether it's Twitter or it's Instagram, these guys usually have some APIs, and you can get an API code, because I should not be able to suppose you give me that automation program, I should not be able to like on your behalf, right? That's not
Yes.
fair. So you basically have to get an API code from Instagram. I mean, I don't know if it exists for Instagram, but I know it exists for Twitter and Facebook. So I'm guessing it's there for Instagram as well. And using that API code, you can actually programmatically keep pulling the posts that come to your account, and they will come in some sort of JSON. Okay, they will have some sort of JSON metadata, and you have to parse that JSON metadata, and you have to send requests. So you have to do the filtering that when that is from a person that you would like to like, then go ahead and like. Okay. This is actually an interesting project. Yeah. Let me see if I can send you some pointers. No promises. I might be very short on time, but I'll take a look at some point. Okay. But you try to Google these, whether there is a developer interface for whether there are developer APIs for Instagram or not. Okay.
Okay, sir. Thank you so much.
Right. Right.
Okay, so are there any more questions that Shomdato can answer, would like to answer? Anybody? You can write in the questions as well if you want to. You can write in the questions as well. Anybody at all? No? Well, then it's over to Vipasha ma'am.
Yes, sir. I hope so. There is no such type of question that is coming from our participant. It's a very interactive session. We are very lucky to have sir with us.
Thank you very
Thank you.
much. I'm very lucky to have this opportunity. Thank you.
Okay, sir. Now our 5th day webinar has been completed, and it is now over with such a brilliant speak from Mr. Somdatta Banerjee. And participants, dear participants, please try to join like other programs that are going to arrange shortly from our MCA department. Many more programs are coming up next, and I'm requesting our honorable speaker that in future, if we arrange this type of program, we will be like lucky enough to have in between us in future also.
I hope so too. Thank you.
Okay, sir. So I'm closing the session. I'm asking to our convener, Mr. Shatadru Sen Gupta, is it the time to close the session and close the total webinar?
Yes, because since Shumdata has also finished and there seems to be no questions coming from everybody, as Vipasha ma'am has actually said, I mean, Shumdata, we're very glad we had you with us today, and we do hope that you will join us in the future also. And our students have, I'm sure, benefited a lot from your deliberations. We would like to end the session here, and thank you everybody for joining. Those of you who are listening to this or looking at this through our YouTube live sessions, thank you for joining us for YouTube. And Shomdotto's slides, as well as slides of the other speakers who come before him, will be making them available for everybody, including the speakers, very shortly, maybe in a couple of days. And we look forward to your association with this kind of endeavors in the future. And so, from me and from Vipasha ma'am, with the kind permission of the speaker and Vipasha ma'am. Okay.
Yes, sir.
Shangshoptok, you may please. There is obviously a certificate for this attending this webinar, but you may inquire those directly through email. Yes, we'll be giving you a feedback form. Once you fill in the feedback form, and once we receive the feedback form, we will be issuing you the certificate. And so, anyways, coming back to this, I mean, with Shomdotto's kind permission and with the kind permission of Vipasha ma'am,
It's
we're drawing this session to a close.
Shatatul, just one quick point. Shall I? So I've just created a link for the folder with my talk and stuff. Should I just put it in the in-call messages? Then
if you do that, there are not enough participants here. So I think maybe because it's a Sunday, we only had about 60 plus, but we have about we had about 400 and something plus. So if you send them to me, then I'll be putting that through WhatsApp or through email to everybody.
Sure. I mean, I could just paste it here as well as send it to you. Is that fine?
That's great. That's it. You
Okay.
could send it one now.
Perfect. So I've
the
just put in the link of the stuff I have.
Let me just copy this. You don't need to. I'll just copy this.
I got a question about my LinkedIn profile. I'll put in my LinkedIn profile as well. That's my LinkedIn profile, and as I mentioned, I will upload the celery script that I made, the little celery file that I made. I will make a little video of me running it, maybe sometime tomorrow, and I will upload it in the same folder. So just note the folder. Whatever I have to share, I will share inside this folder. Okay.
Okay, thanks a lot, sir. Will be very much benefited. Really will be very much benefited.
Perfect. Thank you so much.
Okay. So,
Bye-bye then.
and by your kind permission, sir, please carry on.
Oh, yeah. Sure. We're done, right?
Let us just draw this session to a close and have a very nice day and a very nice year, everybody.
All right. Have a great day. Have a great day and a week ahead. Yeah. Bye-bye.
Bashir, please close the session now.
Okay, sir. Okay. So I am seeking permission to all of you who are present here, to our convener, sir, to our honorable speaker, sir, and to all of the participants. I am seeking permission to close the session. So it's closing for today, and this is the end of the webinar. So the webinar is also being closed from today. Okay. Thanks a lot to all of you. for participating in webinar that is being arranged by MCA Department, HALDIA Institute of Technology.
Thank
So,
you. Bye-bye.
okay, bye-bye. The session is being closed now.
তো দূর থেকে আর ইমোজি ছাড়া কি পাঠাবো বলো? দূর থেকে তো ইমোজি পাঠাতে হবে না? Ma'am, is the session being closed now or no? Vibhasha ma'am, is the session being closed now? I think you guys will have to log out because I think the session has not been closed properly. So please log out, everybody.